This amazing panorama shows Glen Torridon region on the flanks of Mount Sharp. Mount Sharp, also known as Aeolis Mons, is located inside Gale crater and rises 18,000 feet from the valley floor. The image was taken by Curiosity rover, and in the past the rover has climbed through Mount Sharp's foothills, reading the rocks for clues about Mars's long ago transition from a relatively warm and wet world to the cold desert planet we know today. Curiosity rover imaged these drifting clouds on Mars. These are likely water ice clouds about 19 miles above the surface. They are also noctilucent clouds, meaning they are so high that they are still illuminated by the sun even when it's night at Mars's surface. Scientists can watch when light leaves the clouds and use this information to infer their altitude. This dark mound is Erosion Hill, which rises about 16 feet above the redder layered outcrop material of the Murray Formation on lower Mount Sharp. Curiosity rover took this picture while examining a linear sand dune in the area. The faint horizon in the distance beyond Erosion Hill is part of the rim of Gale crater. These small spherules in this close-up image were found near Fram crater on Mars. Nicknamed blueberries, these are rich in hematite and provide evidence of a watery ancient environment, as they were probably formed by water below the surface. Curiosity rover has driven many miles since landing in Gale crater in 2012. This view is from 1500 feet above its landing site. The rover has climbed the side of Mount Sharp, a very tall mountain in the center of the crater. All of this dark material is Martian sand that's made up of broken bits of volcanic rock. You can see the ripples that were shaped by the wind. Curiosity had to drive around this massive sand as it climbed Mount Sharp. The air is really clear at this time of year. That's because it's winter when there's less dust in the atmosphere. You can see all the way to the rim of Gale crater, which is about 20 miles away. Curiosity spent the last several years investigating clay-rich rocks that formed in lakes. But now it's entering a region where rocks are filled with salty minerals called sulfates. These minerals form in drier conditions, so this area might show how the ancient Martian climate was changing. It's also starting to see lots of very cool, knobbly textured rocks like these. Scientists think these veins and nodules were created by groundwater. Here, Curiosity drilled a sample of the mission. By studying the chemicals and minerals in this rock, scientists can learn how the ancient environment was changing as they go from the clay region into the sulfate region. And these hills are different from anything seen on the lower mountain. They are rounded, unlike the ridges and mesas seen before. Now let's look ahead to where Curiosity is going. It will soon be entering a narrow valley that should make for some amazing images. On the left is Rafael Navarro Mountain. This nearby hill is huge. It's about the size of a 4-story building. This changing Martian terrain is more than just fun to look at. It can teach many things to scientists. Things like how Mars lost its water over time, or how long did conditions that were favorable to life last. These are just some of the many things that NASA is looking forward to finding out. This incredible image taken by Mars Reconnaissance Orbiter shows a spectacular avalanche on Mars which was captured as it was occurring. In the image, we can see debris thought to be fine-grained ice, dust, and large blocks that fell from a 2,300 feet high cliff. Evidence of the avalanche includes dust clouds rising from the cliff afterwards. This stunning image shows one of the clearest views deep inside a crater on Mars. The image was taken by the Mars Reconnaissance Orbiter and shows a rippling, rugged crater which is located in the Meridiani Planum region on the red planet. Perseverance rover captured this panorama of its first drill site. Scientists are looking for a rock to drill somewhere in this area, which is nicknamed the Crater Floor Fractured Rough Unit. The flat, light-colored stones are informally referred to as paver rocks and will be the first type from which Perseverance will collect a sample for planned return to Earth in the future. Small hills to the south of the rover and the sloping inner walls of the Jezero crater rim fill the distant background of this view. This view of Ferrari-Rubin Ridge shows sedimentary layers, mineral veins, and effects of wind erosion. This area of lower Mount Sharp became a ridge by being more resistant to erosion than neighboring portions of the layered mountain. Here, the wind has eroded portions of the outcrop in unusual ways, so that elongated rock fragments can be seen protruding into the sky. Ingenuity Mars helicopter took off and landed in this video, which was captured by Perseverance Mars rover. As expected, the helicopter flew out of its field of vision while completing a flight plan that took it 164 feet downrange of the landing spot. Then the helicopter returned back to its takeoff site to stick a landing. This image of the surface of Mars shows a thin coating of water ice on the rocks and soil. The time the frost appeared corresponds almost exactly with the buildup of frost one Martian year, which is 23 Earth months ago. Then it remained on the surface for about 100 days. Scientists believe dust particles in the atmosphere pick up bits of solid water. That combination is not heavy enough to settle to the ground, but carbon dioxide, which makes up 95% of the Martian atmosphere, freezes and adheres to the particles and they become heavy enough to sink. Warmed by the sun, the surface evaporates the carbon dioxide and returns it to the atmosphere, leaving behind the water and the dust. The ice seen in this picture, like that which formed one Martian year ago, is extremely thin, perhaps no more than 1,000th of an inch thick. Curiosity rover captured this view showing an impact crater in a location named Jezero. This was one of dozens of impact craters within a crater cluster Curiosity stopped by after completing one of its most difficult climbs ever. This particular crater is estimated to be about 60 feet wide. In the center of the scene is the path back down a slope toward Marker Band Valley, which Curiosity passed through on its way to Jezero. Beyond that are the floor and northern rim of Gale crater. This view shows a network of two-tone mineral veins at an area on lower Mount Sharp. The veins combine light and dark material, and the veins at this site jut to heights of up to about 2.5 inches above the surrounding rock, with their widths ranging up to about 1.5 inches. Mineral veins such as these form where fluids move through fractured rocks, depositing minerals in the fractures and affecting chemistry of the surrounding rock. In this case, the veins have been more resistant to erosion than the surrounding host rock.